Welcome to section 4.1, or also known as 4-1, graphing quadratic function. So in this section, we're going to talk about the basics on what we need to know before we can do any graphing. Once you understand the basics, then you will have the skills necessary to do some quadratic graphs. So let's talk about graphing quadratic function. In a quadratic form or quadratic function, the greatest exponent is 2. These functions can have a quadratic term, a linear term, and a constant term. The general quadratic function is shown below. So the general form is f of x equal ax squared plus bx plus c, where a does not equal to 0. So as you can see, it is labeled where a is the quadratic term, b is the linear term, and c is the constant term. So you might hear me using these vocabulary throughout the semester, but normally I would say the A, the B, and the C. When we're going to be factoring, I'm going to be asking you, what is the A value? What's the B value? What's the C value? So take a closer look. A is just a number that's in front of x squared. B is just a number that's in front of x. And C is just a C number that's by itself. The graph of a quadratic function is called a parabola. To graph a quadratic function, graph all the pairs that satisfy the function. We're going to be following this term, especially for 4.2. Now, continuing with graphing quadratic function, here we have an example of one of a parabola. Now, starting right here, this is due to the axis of symmetry of parabola. The axis of symmetry is a line through the graph of a parabola that divides the graph into two congruent halves. Each side of the parabola is a reflection of the other side. Continuing, the axis of symmetry will intersect a parabola at only one point called the vertex. The vertex of the graph at the right is 3, -3. So going off with this picture here, the blue line is a graph of a parabola. The red dotted line, that is the axis of symmetry. So you see that the red dotted line is going right through the middle of the parabola. And here is the vertex, 3, -3. The vertex is directly in the middle of the parabola. And if you take a closer look, you see that the right side, the right blue line, is a reflection of the left blue line. So take a look at point B and C. So those 2 points, if you take a closer look at the y values, you notice that they have the same y values. And then up here, the 2 points. Our first coordinate point, the one on the left, -4, 10. And then our second point, the one on the right, 10, 10. If you take a closer look, the y values are the same. So if you match each point horizontally from left to right or right to left, they should have the same y value. So there's a pattern from there. But mainly we're going to focus on axis symmetry and vertex, which will help you on how to graph for this section and 4.2. Now let's talk about the basics of how to find these items, the axis of symmetry and vertex. This, make sure to remember, and of course this should be in your notes. Graph of a quadratic function / parabola. It says, consider the graph of y equal ax squared plus bx plus c, where a does not equal to 0. To find the y-intercept is a times 0 squared plus b times 0 plus c, or simply c. So when you're looking for the y-intercept, x is always 0. So what happened here is that they simply plug in 0 for all of x. So again, there's an x squared and there's an x. So simply they plug in 0 for each of the x. did the square of this one, so 0 squared is 0, times a is 0, and then over here, 0 times b is 0. So ultimately, it's 0 plus 0 plus c, which will equal to c at the end. So in short term, to find the y-intercept, it's always the c value, the constant term. The equation of the axis of symmetry. So the basic way of saying this, in order to find axis of symmetry, the formula is x equal negative b divided by 2a, or 2 times a. So if I were to ask you for axis of symmetry, you're going to write it out in this form, x equals negative b over 2a. You plug in the b value, and you plug in the a value. But be very careful that if b or a is negative, if b or a is negative in the equation, then you must include that negative. Because the reason I said you want to be very careful, because in the formula, you see how it's already negative. So be very careful when a or b, or when a and b both have negatives. The x-coordinate of the vertex is negative b over 2a. So if I were to ask you to find the x-coordinate of the vertex, you simply just write out negative b over 2a, plug in b value, plug in a value, and you simplify. So in the graph below, if you were asked to graph, the easiest way is first find the vertex. And if you can find a y-intercept, which if you can graph, simply graph it. Count the distance from the y-intercept to the axis of symmetry. Count the horizontal distance. Match it on the other side. You will get your third point, and then you should be able to graph. That's the easiest way. Now, if your y-intercept cannot fit within the graph, then my next advice would be first find the vertex. Find the next right x value, and then find the next left x value, put in a table, and then you're going to plug in the x value to find the y values.